NIR, that's what's just next to the visible spectrum. So that starts around 780, goes to 2500 nanometers. And from there to 10,000 nanometers, that's what we normally call mid-infrared. FTIR is a little funny because FTIR is actually the technology how you acquire the spectra. The region is called mid-infrared. So that means that when we're looking at the range from 2500 to 10,000 nanometers, that's mid-infrared, and we acquire the spectra with an FTIR instrument, Fourier transform infrared. The technology you choose really depends on the application. I would say mid-infrared, that is FTIR, is the best method because you get the best signal-to-noise ratio, you get the clearest signals and so on. So that's what you choose. If you could choose just whatever you like, that's what you would choose. However, signals are very strong in the infrared, and that means that you can only shine for a very, very narrow, very, very small sample. And that means that sampling errors become a problem. When you're measuring milk, you have to measure through a very thin film. So if it's inhomogeneous, you cannot measure it with mid-infrared. And that's where NIR is good, because NIR can penetrate up to centimeters of sample. So that means that you can measure cheese almost as is. You can measure milk powders in reflection setup and so on. And that's really useful. The drawback of NIR is that the signal is not as strong, and therefore your accuracy or your repeatability will not be as good as if you're using FTIR or mid-infrared. The general rule of thumb is that if you have something with less than 20% total solids, then I would recommend mid-infrared, FTIR, and if it's above, it would be NIR, because that's more kind of a semi-solid or solid sample. The exception from that would be cream, because cream is liquid at very high solid levels, so that's why we still use mid-infrared for cream. There are basically three ways that you can analyze your milk in a process. You can do at-line. That's when you take a sample out and analyze it in an instrument. The frequency you can do that at is very low, so it means that you don't have fantastic control of the process. Then you have online, where you take a sample out through a little tube into an instrument that analyzes, so it does it automatically. But the problem there is that you don't know what's happening between measurements because you take a sample out. So if there are rapid fluctuations in the process, you won't get that. Inline, you're looking at things live, happening live, and that means that when you have dramatic changes, you can see them immediately. Of course, it requires that you have a technology that you can put into the line, and FTIR is difficult because it requires this very thin layer of milk, but it can be solved. And the advantage you get out of it is that in particular your protein measurement becomes much more accurate compared to if you're using NIR, because NIR would probably be the method of choice if an FTIR is not possible. Until now, FTIR has not been used in the process, and that's because it's very difficult, because you need this very thin layer of milk, and how that is handled has been quite a challenge. But you can actually do it if you have some very fine motors. You can control the cuvette so that it can move, and it can move into position. So when the system is CIP'd, then you can have it open so that it's cleaned, and then you can close it again for measurements. The other thing is that stability requires that you need to do some reference measurements from time to time, and you need to do some mathematical tricks in order to not have that reference measurements once every hour or so, because you only have the opportunity every time you have a CIP, and that might happen every 24 hours, for example. So right now we're at the stage that we've just released the MilkoStream FT, which solves the problem of doing references all the time. It can do references every time there's a CIP. It doesn't need any more than that. It can open during a CIP so that it can be cleaned properly between batches. And then it can close through some very sophisticated motor control that into a distance of 35 microns where it's optimal to measure milk in a cuvette. Moving fully inline makes a huge difference because you can control your process to very large detail. So if something is changing, you can see it immediately. And also the maintenance has been reduced quite significantly because we are just using the CIP system inline in order to clean the instrument. There's no specific cleaning or no reference measurement or so on. Everything is happening in relation to the CIP. And finally, there's no flow system, no moving parts to be replaced in the flow system as there is with the current equipment available. The main advantage is that we can measure protein at a very high accuracy compared to competing methods. And that's the reason why it's FTIR in the line and not any other method.